Welcome to yet another episode of Wave of the Day by Smallest. I'm your host, Emily, joined by my brilliant co host, Armin. Today, we're diving into something that's revolutionizing natural language processing, but, and no, we're not talking about Sesame Street's beloved character.
I'm sure that Bert would be fascinated by his artificial intelligence namesake. Today we're talking about bidirectional encoder representations from transformers, quite a mouthful, right? It's an incredible breakthrough from Google that's changing how machines understand language.
You know what's fascinating about BERT? It's like teaching someone to read by occasionally covering up random words in a sentence and asking them to guess what's missing. It's such an intuitive approach when you think about it.
Exactly, and what makes it really special is that it looks at context from both directions, left and right, unlike previous models that only looked at text in one direction. Think of it like trying to understand a conversation. You don't just listen to what came before, you need the full context.
That reminds me of when we try to solve crossword puzzles. We use both the words before and after the blank space to figure out the answer. Is that similar to how BERT works?
That's actually a brilliant analogy, Emily. Yes, BERT uses what they call a masked language model, where it randomly masks or hides some words and tries to predict them based on both the left and right context. But here's the clever part, it doesn't just mask words, it sometimes replaces them with random words or keeps them unchanged.
Wait, why would they replace words with random ones? That seems counterintuitive.
Well, think of it like this, if the model only ever saw mask tokens during training but never during real world use, it would be like practicing for a game with different rules than the actual match. By mixing things up, they help the model stay robust and adaptable.
And how effective is this approach? I mean, are we seeing real improvements in language understanding tasks?
Oh, the results are incredible. BERT has pushed the boundaries on 11 different natural language processing tasks. We're talking about improvements of up to, say, 7% on something called the GLI benchmark, which is like the Olympics of language understanding tasks.
That's impressive. But let's break it down for our listeners. What does this mean in practical terms? What can BERT actually do?
Great question. BERT excels at tasks like question answering, sentiment analysis, and figuring out relationships between sentences. Imagine having a conversation with a computer where it actually understands the context and nuance of what you're saying, not just matching keywords.
You know what's really cool? The fact that BERT can be fine-tuned for specific tasks without major architectural changes. It's like having a versatile athlete who can excel in multiple sports with minimal additional training.
Absolutely. And what's even more fascinating is the scale of this model. The base version has what 10 million parameters, and the large version has 30-40 million. It's like having a brain with hundreds of millions of tiny adjustable connections, all working together to understand language.
Those numbers are mind-boggling, but I'm curious about the training process. How much data and computing power are we talking about here?
They trained BERT on a massive corpus of text, the entire Wikipedia, and something called the books corpus. We're talking about over 3 billion words. The training took 4 days on multiple TPU chips. It's a testament to how computationally intensive modern AI has become.
It's amazing how far we've come in natural language processing. From simple rule-based systems to these sophisticated neural networks that can understand context and nuance. What do you think the future holds?
I think we're just scratching the surface. BERT has shown us that pre training models on massive amounts of text can lead to breakthroughs in understanding. The next frontier might be models that can not just understand language but truly reason about what they're reading.
Well, this has been absolutely fascinating. Thanks for breaking down such a complex topic in an accessible way. To our listeners, remember that while BERT might sound technical, at its heart, it's about making computers better at understand human language, something that affects all of us in this increasingly digital world.
Couldn't have said it better myself, Emily. And for anyone interested in diving deeper into BERT, we'll put some resources in our show notes. Until next time.